Okay.
All right, we're back for part 2 of today's lesson, which is going to be on metamorphic rock. So you want to think about how the word metamorphosis basically means change. Metamorphosis literally means changed form. So for metamorphosis to occur, one type of rock has to be completely changed into another type of rock. It cannot be changed from a liquid. It has to go from a solid to a solid. And in order for this to happen, we need to apply heat and pressure. However, heat and pressure to varying degrees form different types of metamorphic rock. There is low impact, and then there are high impact metamorphosis that take place. And we're going to talk about that by taking a look at what happens with shale, and how shale can go through several stages of metamorphosis and become several different types of other rock. So the first thing that we have to know is that rock has to be subjected to high pressure, high stresses, high temperatures, all right? So igneous rock, sedimentary rock, and metamorphic rock can all go through a process of change to become something else. This process usually occurs deep underground at depths ranging from a few kilometers below the surface all the way down to the crust mantle boundary. Metamorphosis can change a rock's texture, size, density, and mineral makeup. So it can literally create so much pressure that it breaks chemical bonds or atomic bonds and forms other ones. So it can completely change a structure. Minerals cannot go through a melting process. So minerals do not revert back to a liquid before they metamorphize. They have got to stay in some type of a solid form. What happens is they recrystallize. So recrystallization occurs when the crystal structure, the original crystal structure, collapses, and under the influences of temperature and pressure, they reform into something else. Recrystallization happens again at varying degrees. I'm going to talk about low-grade metamorphosis. This is for example, if we take the sedimentary rock shale with a small amount of pressure and a small amount of heat, shale will become metamorphic slate. So it becomes a slate. We also have something much different where a very high-grade metamorphosis takes place. And this is called shock metamorphosis. And this might occur when the mineral shishivite is formed, and it can be formed from a silica. Now, shishivite is a very interesting thing because if you think about it, this is an extreme case of where an enormous amount of pressure causes rock to metamorphize. And where we first began noticing shishivite is around the sites of meteor impacts. So we first began seeing it there. And if you can imagine, and we've talked about this before with Meteor Crater up near Flagstaff, the impact of a meteor striking Earth, particularly a large one, is so much pressure that it literally creates a crater in the Earth. But in addition to that, it creates a completely new rock form, and that is shishivite, to where that impact is so instantaneous and so extreme that it automatically causes a recrystallization process and realigns the atomic structure of atoms in rock to create shishivite. We now use shishivite and the presence of shishivite to determine whether or not there's even been any type of a meteor impact in an area. So that is an example of where extreme metamorphosis takes place. All right, so the other thing we want to talk about is foliation. With foliated rocks, minerals are aligning in a particular direction. So they'll be forming parallel layers that will look like the pages of a book. They'll be lying on top of one another. Minerals are usually oriented in a perpendicular manner. So when metamorphosis takes place, we'll see a realigning again because of that heat and pressure. I want to to summarize metamorphic rock, I want to talk about shale. So when a little bit of heat and pressure is applied to shale, it will become slate. When we have slate and a little more heat and pressure is applied, the slate will become schist. And then when we have even more heat and pressure applied to schist, that becomes gneiss. And so we have an example of where varying degrees of heat and pressure can take something like the sedimentary rock shale and transform it 4 different times and to 4 different substances. And that's a very easy trail that you can look at examples of where and how these crystals are going to reform to create new substances. So again, heat and pressure, rock cannot go back through a liquid process in order to metamorphize. It has to remain a solid, and it has to be heat and pressure that breaks down the atomic structure and causes it to recrystallize or realign. So we've gone through, and again, I do want to reiterate, when rock melts, when the minerals in rock melts, it goes back to magma. It's not rock anymore. It's liquid magma. It's liquefied rock. So those are the basic 2 things. So again, to summarize with metamorphic rock, we have to have high pressure and we have to have high temperatures, but to varying degrees for things to change. It's a recrystallization process rather than a melting process. Igneous rock can go through metamorphosis. Sedimentary rock can go through metamorphosis, and metamorphic rock can go through metamorphosis to become something else. All right, so there's this constant shifting and changing. Remember, metamorphic rock forms in the earth under heat and pressure. Remember that it can never re-liquefy. Once it does that and it hardens again, it becomes igneous rock. All right, so that's the basics of metamorphic rock. You've got a specific video on metamorphic rock as well as igneous rock. And then there's the introductory video that talks about the 3 different rock types. Please go through those. You have my lecture notes already that have been sent to you on all 3 of the rock types. So please read through those to make sure you understand those as well. Tomorrow we will be beginning our work on sedimentary rock. That's actually going to take several days. And we're going to be, I will actually be sending you a PowerPoint, and I'm going to use the Grand Canyon as an example of how we look at sedimentary rock and how we learn about our Earth from sedimentary rock, so that you understand how non-simple, I suppose, the sedimentary rock can be as we start studying it. With sedimentary rock, we also have to take a look at weathering and erosion as part of how it forms and what occurs. And then we're going to also be taking a look at limestone. And I'm going to give you an experiment to do at home regarding limestone, and all you're going to need is what you have in your kitchen and in your backyard. So look out for the first video on sedimentary rock tomorrow, and I will see you then. Bye.